So welcome back to the fourth and final lesson in our short series on finding the shortest route from a start node to a target node. In this lesson, you'll use the A-star algorithm to find the route quickly and efficiently. So in this lesson, we'll look back at the task that I set at the end of the last lesson. You found a route using Dijkstra. In this lesson, we'll work together through the same task using A-star, and then the lesson concludes with some exercises for you to try for yourself. So in the last lesson, you had to find a route through the cities of Europe from D to J. If you've completed this activity, your table will probably look something like the picture here. You'll see that every single node or vertex in the map has been visited, which was quite a lot of work. I don't know how long it took you, but it was quite an intensive activity. Now we're going to do the same activity using A-star. That involves these stages. We'll add a heuristic to each node. As we work through the table, we'll calculate the A-star value by adding the heuristic, and then we'll use the A-star value only at the point when we pick the next node, and we'll always pick the node with the smallest A-star value. So we just need to prepare before we begin, and what we've got to do is obtain a heuristic for each node. We're going to extend the table to add columns to show the heuristic and the A-star total, and then we'll fill in the table with all our heuristics. Of course, obtaining a heuristic is a new task that people have to do if they're using this algorithm, but luckily you don't have to worry about that. I've provided some heuristics here, and if you were doing it in the exam, they would provide the heuristics. How can you tell which numbers are the heuristics? Well, in this example, they're written in red, but that's not really what tells you. The heuristics are joined to the nodes. They belong with the nodes, whereas the Dijkstra values are attached to the links or edges. So we're adding some new numbers to our graph or map data structure, and these numbers are heuristics, and they're associated with the vertices or nodes rather than with the routes. That means we can write them in. So let's see how that looks. We've got to extend the table so that we add two new columns, one for the heuristic and another where we'll put the A-star totals as we work those out. And here's our table. It's the same table as before, but I've added two new columns, one for the heuristic number and one for the A-star total. And I've filled in all the heuristics for each of the vertices in our graph data structure. So we're ready to go. There's the graph on the right, and here's our table ready to go on the left. So what's the first thing we do? We're starting at position D, and the first thing we do is find all the nodes that we can get to from node D. So let's just fill that in. I can get to A, B, C or E from position D, and I'm filling in all the distances. A is 25, B is 30, C is 50 and E is 75. Now if we were doing Dijkstra, the next active node would be A, because A has got the smallest distance from D. You can see straight away that's taking us in the wrong direction, so it illustrates very clearly what is wrong with Dijkstra. Dijkstra takes us in the wrong direction at first. Don't get me wrong, Dijkstra will get us the right answer in the end, but it will take us on a lot of alternative routes on the way to getting the right answer. Okay, now let's do it using A-star. I'm going to work out the A star total for each of these nodes. So for A, the A star total is the distance 25 plus the heuristic 200, and that gives us an A star total of 225. So A, because it's a long way from our target, it's right at the other end of the map from our target, it ends up with a big A star total. B similarly ends up with a total of 130, and C with a total of 220. That's the distance 50 and the heuristic 170 gives us an A star total of 220. Whereas E has an A star total of 125. The distance 75, the heuristic 50 gives us a total of 125. Now, instead of choosing A, which has the small value in the distance column, we look down the A star total column and it's clear which has the smallest value, E, because it has a value of 125. It's the smallest value in the A star total column. So E becomes our new active node. All the other nodes up at the top of the table have been eliminated straight away. We're heading in the right direction. We've got far less work to do. And let me just complete the table. It'll only take a second. So we go from E to H and from H to J, 2 more calculations, and we found our route. We only really visited 4 nodes, the correct 4 nodes. This works because we've got a good heuristic. If we didn't have a good heuristic, this wouldn't work. But because we've got a good heuristic, it's eliminated all those false routes, and we've just gone straight there. I just want to reiterate this. We've ended up with the same answer. If we'd done Dijkstra, we'd have ended up with the same answer. A distance of 125 going D, E, H, J. It's just that the A star method has got us to the right answer much more efficiently with less work. Less work for us, so it's all good. Okay, so I hope that showed you how the A star algorithm works. I've got 3 exercises now which will follow. Calculating the route from Dallas to Boston using Dijkstra, then doing the same route using A star. I'll give you a heuristic so that you can do the A star algorithm. And then finally one that's set in Essex and you find the route from Clacton to Dunwich using the A star algorithm. So I'll just bring those up in a moment and go very quickly through them. But if you're my student, I'll be giving you a handout, a Word document that's got the picture and the table ready-made for you so you can do it more efficiently. But try all 3 of these because A star and Dijkstra are almost certain to come up in the exam. So it's easy marks. If you know how to do them, they're easy marks. Okay, so here are the 3 exercises. Here's a map of different cities in the USA with routes, and you've got to find the quickest route from Dallas to Boston. And you can't use A star for this because I haven't given you any heuristics. So use Dijkstra. And then here are some heuristics. Extend the table to 2 new columns, copy the heuristics in and do the same thing but use these heuristics. You'll get the same answer but much more quickly. And then finally, with no help, I'm just telling you, use A star to find the quickest route from Clacton to Dunwich and just see how you get on. If you're my student, you can pass me your results so that I can see that you've learned this topic. And it will also come up in the mini mock exam that we'll be doing at the end of this week.